Hi everyone, my name is Anna. I'm a senior software engineer working at a firm. We are a fintech company that provides honest financial products that help people with their purchases. Today we're gonna do an overview of what is. First, I'm just gonna introduce like what is a firm, and then we're gonna quickly go over what is CICD, and then we're gonna look at some differences in how the different CICD platforms do some things like hosting and configuration. And I'm gonna tell you like the story of how a firm got from like using Jenkins for everything, and we have tests that run for like over an hour and pretty flaky to where we are today. And then in the end, I just have some learnings that I found useful when I was doing all this. Yeah, cool. So first, what is a firm? We offer point-of-sale installment loans with 0 fees. So what that means is that, say you're buying some large ticket items online from like Walmart, or actually not just online or offline. If you're buying something from Walmart and then at checkout you're like, I don't want to pay with my credit card today, and then you can just say pay with a firm, and then a firm will pay the merchant upfront, and then you can pay a firm back over, you can choose a term like over 3, 6, or 12 months. So the nice thing here is that if we say, well, sometimes it's 0% interest, which means you never have to pay any interest. Sometimes if we say it's, see here it says $20 interest over 6 months, it's definitely going to be $20 over 6 months. If life happens and you have to pay a little bit late, we don't charge any fees, and we don't compound your interest. We don't charge any deferred interest. That differentiates us from most of the other credit card and installment loan companies. So for example, like if you go into a store and you like Macy's, and at checkout you'll probably, someone might ask you to sign up for a credit card. And usually how that works is that you get a quote unquote promotion and say $50 off this purchase if you sign up for our quote unquote 0% interest credit card. And then you don't have to pay anything for 12 months. But then at the end of the 12 months, if you have like 1 cent that is not paid off, then they will charge you deferred interest that is calculated based on the whole purchase amount when you like that you did all those time ago. So like it could easily amount to a few hundred or even thousands of dollars. So we think that is just not ethical. It misaligns the company's interest with the customers. Like companies shouldn't profit based on their customers' mistakes, right? So for our customers, we are just a more transparent way of paying than their credit cards or our competitors. And for merchants, we just merchants choose us as their partners because we can give them a higher approval rate. And with these pay over time options, customers tend to buy more things in a single order. So AOV stands for average order value. So they can sell more things. So the merchants are happy with us because we help them grow their business, and the customers are happy with us because we don't charge them anything out of the blue, unexpected. So, and we're happy because we make money doing this business. So it's sort of a win-win situation here. All right. So next up, what is CICD? A quick overview for people who are not familiar with this term. CI is continuous integration. Basically, it means you should check in small changes frequently. And when you do, those changes should be built and then tested automatically. This allows you to detect any errors as quickly as possible and avoid any compounding problems. What that means is that, imagine in the past, what a lot of companies did was that usually you don't release every day, right? And you don't test for every commit that you push. What a lot of them did was everyone would push to a release branch or just master, and then a release gets cut every week or every month or like even every couple of months. And when that happens, a lot of testing will start. And also a lot, not just automated testing, a lot of manual testing as well. The problem with that is the release time and testing time is so far away from when people actually wrote the code. If you actually detect some errors, it's really hard to figure out why. And then also, like, chances are there might be like other features that have arisen based on problematic code that landed that wasn't found because there weren't enough testing up front. So continuous integration encourages you to do exactly the opposite of that. Test as frequently as possible, check in smaller changes so that everything just gets iterated quickly and you can find out anything wrong, if there is anything wrong. And then after that, you have CD, which is continuous delivery or continuous deployment. So this is just saying that after you're checking your changes, they should get automatically deployed to staging and then eventually to prod. And this forces you to make sure that every change you make is releasable. So if you have anything that you're not sure of, you should put it behind a feature flag so that you can turn it on and off without re-releasing the code again. And also the nice thing about this is that, again, because changes are small, you have way lower risk of releasing each change instead of, say, you're doing hundreds of commits in one go, then just it's a lot more heavyweight that way. Yeah, and then you can, because you're doing so many releases, like now I think a lot of companies are doing like dozens. Some companies probably even do like hundreds of releases a day. You also get tighter feedback loop. Like you write a small feature, you can just release it right away, and then you know that it has worked or it has not worked. Right, great, and you can get on with the next thing you want to work on. So this CICD concept just kind of empowers the engineers to feel like they have control over their code. They don't have to wait for someone else to deploy their code, and then they don't have to wait for the next release cycle to know what they worked on, whether what they worked on is working or not. So yeah, it's great. And yeah, here's just a quick graph of what it looks like. I took the graph from GitLab CI. So here you write your code and then you commit it to like your source control, GitHub or Fabricator or whatever. And then it gets built, tests, unit tests, integration tests, and then after you land it, it should go out automatically. And over here, I have some of the most popular CI/CD platforms. Over here, we're gonna we're not gonna go over every one of them. We're just gonna go over some of them. But anyway, like, yeah, if you're not Google or Facebook and have like your own huge DevOps team, you're probably using one of these. I saw someone asking about Azure DevOps in the question app. I didn't look at Azure. before because we're using AWS. Like took a quick look before this session, and I feel like my feeling is that it's pretty close to AWS CodeBuild, and maybe also Circle CI. That's my feeling. I'm not sure. Again, I just looked at it for like 10 minutes, but it should be close to one of these. Yeah. Over here, I just have some quick notes on some of the more interesting ones, in my opinion. Jenkins is probably the most popular platform out there. It's been around for 15 plus years. It's probably I would say it's the first platform that really took off in the CICD world. And then Buddy is like a hero code, but for CICD, so it's like really easy to use and simple and pretty. BuildBot focuses on flexibility and scalability, and BuildBot is my impression of it is like it's like Jenkins, but slightly better, also in Python. So I don't have to work with JVM as much, and garbage collection is not such a huge pain. Yeah, and then AWS CodeBuild and TeamCity are both backed by another larger company. Like AWS is obviously by AWS. TeamCity is by IntelliJ, the IDE company. An interesting thing is that they use Kotlin DSL for pipeline configuration, which makes sense. They also wrote Kotlin, the language, is also made by IntelliJ, and it's mostly used for Android right now. This is the first time I saw it also gets used in something else. All right, so yeah, next thing I'm going to talk about is like some differences in the way they do things. So like CICD has been around for 15 plus years, but a lot of them, like there's still no clear standard on what each of these platforms should offer. Like being able to build in parallel sounds like a pretty standard feature, but not all of these support that, which is pretty surprising. So next, I just wanted to look at two of the features that all of them do differently and kind of compare the pros and cons of each approach. So the first one I have here is hosting, like just where your CI server and workers are run. Oh, here I should say the way usually CI works is that you have a server and then you have a bunch of workers. The server will handle like the request for builds and then just tell the workers what they should do. Right. And we have, and I have a graph here. Here Jenkins is the server, and then it just controls a bunch of machines as its workers and have them do their work. So these are the platforms that offer on-premise. On-premise hosting, meaning like you can run a copy of the server and all the workers within your own infrastructure. The nice thing about that is that it's usually cheaper compared to hosting on cloud, especially if you're using open source software like Jenkins or BuildBot, then you don't even pay a license fee. So I see a lot of companies when they're starting out, they just run a Jenkins instance or like BuildBot or some other open source platform, and then that can get them going for a few years, maybe 4 or 5, maybe even longer. And they don't even have to pay anything besides paying for the machines. It's like the next thing is that it's really secure. So because everything running your own infrastructure, you don't need to worry about a third-party software getting access to your source code or your prod machines. Like for us specifically, we are a fintech company. We handle people's sensitive information and their money. So like for us, it's just we will never use a purely cloud-hosted CI/CD platform, because then it would mean that we give some other company access to our servers to deploy to, and that is just too big of a risk. The downside of on-premise hosting is that it might be a lot of maintenance work, especially if your engineer team is growing. And some of these platforms offer support if you pay a premium, but like at the end of the day, you're still gonna be the one who does most of the work. And if the organization is not set up to work like that, like if you don't have a large DevOps team, this might be a problem. You might end up having all your time trapped in maintaining this platform. And then also because it's because sometimes it's so much work to maintain the platform, that the CI servers and the version of software that run on workers may not get updated as often as they should be. And as a result, they might actually not be as secure as you will want them to be. Like Jenkins is a great example. It has tons and tons of security vulnerabilities in the older versions. But I know a lot of companies are still running the older versions because it's actually, there's a risk when you upgrade your Jenkins version that some or all of your pipelines will stop working, or just work in a very funky way. So a lot of people would rather not update them, but then those security risks are just sitting there. And then, yeah, next we have cloud hosting. Here, these are the guys that offer cloud hosting. I put TeamCity in gray because it's currently in beta. I think it just came out in 2020. Cloud hosting compared to on-premise is obviously a lot less maintenance work. You now have you just have the option to solve the problem, like throw money at the problem, right? Like you don't have to, if you want more machines, like more concurrent builds, you don't really need to do anything. You just tell them, hey, I want more, and then they will give you more and charge you more money. And also it can easily become expensive because it's really easy. It's a lot of these cloud hosting platforms charge not by user, but by the number of concurrent build you want to run. And also sometimes also by like the size of the machine, which makes sense. But it can easily be, I think I looked at, I wouldn't say which one because I don't have my spreadsheet up here, but at least one of these charge, if you want to run 100 builds, is something like $20,000. Yeah. So it's usually for smaller companies that are not doing as much yet, and you just use it because they're so easy to use, and you don't need to even have a developer tools team to take care of it. And the downside of that I just mentioned before is that it might be a security concern because these platforms will have access to your source code and also like your prop machines. If they get attacked, I think Circle just recently had a security attack. I don't remember about the other ones, but Circle definitely did. If they get attacked, then the hackers could easily get onto your prop machines, and terrible things can happen. Right, on to the next one. Hybrid is like a mix. between on-premise and cloud, obviously. So what that means is that you have the CI server hosted on their platform, but then you bring your own workers. So the workers will still run on your infrastructure, whether it's AWS or Azure or your physical machines, any one of them will work. Now that implies that your source code and your secrets and other things can stay on your side of the infrastructure. They will not, their server would not be able to touch it. So far, I've only seen 2 providers provide this. One is BuildKite, the other one is GitLab. I put a question mark here because I only saw it mentioned in their pricing page, and then I didn't see any docs for it. But I think they do provide it. I'm just not sure.
I can confirm that I'm using GitLab in a hybrid mode.
Nice. Yeah, cool. I should take out the question mark then. Thanks. Yeah, so hybrid, I personally like the hybrid way the most because it kind of gives you the benefit from both worlds. It's less maintenance work than on-premise because actually most of the maintenance work that needs to happen will happen on the CI server. But in this case, the server is hosted. You don't need to worry about it. And the other nice thing is that it's more secure than cloud hosting, because again, your code and your secrets are all on your side of the network. But still, it's not as secure as on-premise. There's still some security concerns. If we go back quickly, they communicate, the agent basically take commands to run from the server. So if the server gets hacked, and potentially they can send you malicious commands to run on your machines. But there are ways to prevent this from happening. Like, I don't know about GitLab, but BuildKite lets you configure things like only allow commands that are checked into my source control to run, so to make sure that these are no arbitrary commands are running, right? And also we're also working on something like just containing everything in a secure container and only allow certain things to go through that container to just make sure that everything's running there, are like in the extremely limited list of what we wanted to run. Yeah. Any questions here? Nope.
Could you please explain what the use for the workers in the CI/CD pipeline?
Oh yeah. So the workers are the ones that actually do things. So the server, the only thing that the server should do is that, you know, it might be listening to webhooks, or it might be listening to Git. And whenever it sees a build need to happen, it kind of just lists out all the commands, some like the job need to run, and then it passes it on to the workers. It will say, worker 1, please build a Docker image, and worker 1 will go actually build the Docker image. So these things like building Docker images or like running tests, these things shouldn't happen on the server node, because it can, like, imagine you want to build 10 or 20 concurrently, then like the server node wouldn't be able to handle it, right? It should just give it to someone else to do. And then when the worker is done, it would tell the server and be like, I'm done. And the server would tell the user via a web interface or something. And then the user will see that the job is done. Does that make sense?
Yeah, but I have like more questions about this. So the workers works sequential, or they can do this parallel, and who manages these works?
Yeah, that depends on the platform. So some platforms just natively support building in parallel, which means the server can talk to many different workers at the same time, and then it can orchestrate different steps on different workers and on the same time. Like Jenkins, oh, I know about Jenkins, so let's say Jenkins. The way Jenkins works is that you give it a like you define first, user define how the job should run, right? Let's say first step is build Docker image, and then wait for that to get done, and then use this Docker image to run tests, right? Let's say it's just these two steps, and then the Jenkins server, when you say I want to run a build, the Jenkins server would look at your build configuration. It depends on how your build is configured. It might do some like parsing of your code, and basically it transfers it into like this Jenkins specific internal language, and then it boils it down to a few commands, and then it just sends it to the worker and say, okay, now run this, run Docker build, and then the server, the worker will run it, and then it passes an okay back to Jenkins, the Jenkins server. Jenkins server would then say, okay, now actually run the test, and the worker will do that. If the run test can be parallelized, if the user says the run test step should be parallelized, Jenkins server would just quickly tell maybe 5 workers to say run this test, and the 5 of them will get the same command, say run test, and then they would do it. Does that make sense?
Yeah, I kind of know how it works. So that's for Jenkins, that's user defined. But I'm curious about the things that because the CI pipeline just passing the test, right? Is there typically any efficiency requirement for the CI pipeline?
Yeah, like I would say speed is everything, because like imagine if you're an engineer and you have to wait for an hour for your test to run before like doing anything else, right? It's just you would like context switch so much. Like you're checking your code, and then you gotta find something else to do, and then you need to remember to come back after an hour to look at your test. That's just painful, right? But imagine it finishes under like 5 minutes. You might just go get a snack or coffee, and then when you're back, tests are done. Like, yeah, I would say as quickly as possible. Ideally, definitely under 15 to 20 minutes would be great. I feel like anything longer than that is like the engineers might be okay with it, but it's just not ideal because it kind of wastes everyone's time.
Okay, thank you.
No worries. Oh, I just remember another thing about that is, imagine if your tests are flaky. We're going to talk about this later. But imagine your tests are flaky, it non-deterministically pass or fail. And on top of that, your tests take an hour to finish. So now what happens is that you check in your code, you kind of wait for an hour, you do something else. And then when you come back, you see that your test failed, but then for something that you like, that you totally didn't touch, that can't be you. And then you just have to rerun everything. And then you wait another hour and you come back, and it might pass or it might not, right? And from the engineer's perspective, that's just a very painful experience. Does that make sense? So I would say the faster the better.
I have another question, like regarding the security concern, like with this hybrid mode. So
which one?
with the hybrid mode, you said there's still
Yes.
some security concern. So
Yes.
yeah, I'm wondering, like, is it that the build kite like orchestrator can send whatever command to all the workers? Is that
Yes.
the source of the concern?
Yes, that is.
Okay, but I thought like the commands like all the workers receive, they are also like created from like one of your like node or like host.
Yeah. Usually it is, right? But if, like usually if everything is going well, they're just running what we tell them to run. But say their server gets hacked, and our agents are still connected to their server and listening to what their server has to say. And
I see. So it's like a middleman attack, even though like all the command originate from one of the agent master from like the on-prem side, the traffic can get hijacked and like corrupted. I see.
Yeah, exactly.
Yeah, but yeah, but
sorry, go ahead.
And that's why you mentioned like you guys now start screening like all the commands and see if they are if they are like from the whitelist or something.
Yeah. Like I don't know about GitLab, but BuildKite has this pretty easy to configure thing that lets you specify like some whitelist, and also or just say that it has to come from a checked-in piece of code from my Git.
Gotcha.
Yeah, and then there are like some other things you can do as well. And also, you probably want to isolate these worker nodes from the rest of your like pod machines and things.
Yeah, for sure.
Like put them in different VPC, and then so that if say like someone got into these machines, they can't jump from here to somewhere else. Oh, anyone else? Cool. I'll continue. So next thing is how people do pipeline configuration. So everyone would offer some sort of UI configuration like this, right? You put in the name of the pipeline and where to put your code, and then a list of commands, maybe some environment variables, and then you would click save, and then that's your pipeline. But by now, pretty much everyone had agreed that doing it all in the UI is not the best idea. You know, we're engineers, we want to put everything in code. So different platforms have come up with different ways to let you configure your pipelines in code so that you can check in the Git, you know, like prevent some fat finger errors and revert to a previous version if you'd like. So everyone has agreed that pipeline as code makes sense, but so far they haven't agreed on which way is the best yet. The most popular way is definitely YAML. So you would basically configure something like this. It can be really simple. It can be done in like 4 or 5 lines. Basically, you just say, I want to run these scripts. These are my steps, and then you're done. So the nice thing about configuring pipeline in YAML is that it's really easy to read and write. The not so nice things are it's not flexible. You know, YAML is a declarative language. You can't have any logic in it. Say if you want your pipeline to run this thing, if I have this folder in this repository, but not run it, if it's not there, that is not doable in YAML. You've got to have 2 copies of it. And then it can also become pretty bolded. So here I have an example of one of the steps in one of our jobs. So for every build, we can easily have hundreds of these steps. It's just not possible to write it all in YAML. Like even one of these is already kind of hard to read. And like if I want to change something here, I would probably, it's just not that easy to see what needs to be changed. Right. Another way is some of these platforms that you configure your pipelines using a DSL or just regular code. Most of them use a JVM language for some reason. I don't know. The only different one I found so far is BuildBot, which is Python. The nice thing about that is the exact opposite of YAML. It's really flexible. You can do whatever you want. It's just like writing regular code. So you can, yeah, you can be like, read a file and then based on what's in that file, run, and then for each of the result I get here, run the build. This is just impossible in YAML, but really easy to do with code. And also it's testable if you wanna extract some logic out and then put them into methods, you can even test them. The downside of this is that we were actually using this way before. We were using Jenkins. We had pipeline in both Groovy DSL and then regular Groovy. We pretty quickly realized that too much freedom can be a problem. So because we could write code for everything, because the code let us do anything we wanted, we pretty much did anything we wanted. We had put things that shouldn't have been in our pipeline configuration in there. And that causes two problems. One is that your pipeline configs are just get larger and larger, and it's very hard to maintain. And the other one is that you might have some unexpected performance issues. So again, Jenkins as example, once we had this engineer who wrote this piece of logic that just read some files and then figure out what other tests need to run based on this file. It was pretty straightforward. He did it in Groovy when he could have done it in as a step in the pipelines, but he did it as part of the pipeline configuration code. And that added 20 minutes to every pipeline run. So, I mean, Jenkins is to blame partly, but also we probably shouldn't have put that code into our pipeline configuration anyways, because it could have been as part of a step. So still way here is that you write some code and then the code will generate a YAML file and that will be turned into a pipeline. So far I've only seen BuildCare doing this. Correct me if I'm wrong. The nice thing about this is that you can basically use any language you want, as long as it can generate YAML, as long as it can write to standard output. And it's also testable, just like the DSL/code way. It's my favorite part about this. It enforces a clear separation between the logic of deciding what should run and the orchestration, which is the part that actually runs things, which is the YAML part. So this is like if you worked on the UI side of things. I was an Android engineer before, so I like to use this example. It's like when you're doing UI, you like to separate your views and your presenters, because then you separate concern of each. The view should be very dumb. It should only care about showing a pop-up, and if it doesn't, and then any click, any logic should be passed on to the presenter, and the presenter should decide what happens. And the really nice thing about that is your presenter is completely independent of any UI elements, and then it can be independently tested versus, and same thing with our build pipeline logic. If your code is only used to generate a piece of YAML, then like all of your code is testable. Versus if you have DSL and code with like some pipeline libraries calls in between, then you can't test those. And that, when we were using Jenkins, that was a huge problem for us. Is there any questions over here? I feel like that was not very clear. No?
Do you have any idea that why the YAML file is essential for configure the pipeline?
Like in this third way, or
like why don't they use like JSON or other?
Oh, I think YAML is just easier to read. You know, like let's find a YAML example over here. Okay, like this in JSON is probably, it's just like a lot more curly braces and extra things. In my opinion, YAML and JSON are pretty interchangeable, but people have just decided on YAML, and I do think it's a little bit easier to read and write. You don't worry about curly braces and that kind of things. I think the reason that BuildBot came up with the code to YAML and not to like JSON or some other way is that because they can reuse this upload for their other pipeline configuration scheme as well. Like BuildBot support both configuring with YAML and configuring with code and then generated YAML. Right, like the second part of that is just reused. The YAML part, you can like whether you write a static YAML and save it in your repository and upload that, or you write some code and you generate some YAML at runtime and upload that. They don't really care. YAML is just this one unified interface for them to manage things. Yeah. Does that make sense?
Yeah, thank you.
Cool, thanks. Oh, next up is story time. I'm gonna tell you like the story of how a firm switched from Jenkins to BuildBot, why we did it, that kind of stuff. So back to the beginning of January 2019, where it all started. So in January 2019, oh, I forgot to say, sorry. So back then we used Jenkins for everything. We have 4 Jenkins servers, 2 for testing, 1 for stage deploys, and 1 for prod deploys. For each commit that gets pushed to, we use Regular. So for each diff that gets pushed, we will run tests that get parallelized between 20 to 300 concurrent builds, depending on which service you're testing for. So in January 2019, right after the holidays, after people came back to work, our testing load jumped from 30,000 builds a day to 50,000 builds a day. As a result, this was really hard on our Jenkins servers. They would become unresponsive or slow enough that they would have to be restarted during the workday. So everyone would get blocked on our CI platforms. And on top of that, our tests were really slow. Some of our pipelines would take over like 70 minutes to finish. And tests were really flaky and builds would fail. not because of bad code, but because resource contention workers node got disconnected, database weirdness, that kind of stuff. So our engineers really lost trust in our CI tests. When they see something fail on their diff, the first thing they want to do is to rerun everything a few times before they start looking into the issue. So that also added to the load. So at this point, something major need to be done to our platforms to support this load. And also we started thinking whether we should stay with Jenkins, right? Given all the problems we had with it. But we couldn't just decide on a way to go right then and be confident that that would be the right way to go. Because first, we've been using Jenkins for like about 5 years at this point. All of our pipelines were configured in Groovy, which is like a thing that only Jenkins uses and no other platform will use. So that means we're pretty tied up on Jenkins. It would take some time for us to decouple our pipelines and move it somewhere else. And on top of that, we had a really small developer tools team. We actually only had a team of 1, which was me working on this problem at the time. So we just didn't have the time to even properly evaluate the possibility of switching to somewhere else. And without proper research, it's very likely that after spending a huge amount of time moving to a new shiny platform, we just find ourselves in a situation where we had traded the problems we had with a new set of problems, and we would just have wasted a bunch of time. So we didn't want that. And the third thing was we decided pretty early on that we don't want any additional Jenkins instances in this fleet. We want to keep it at 4. So here, some context on Jenkins. Scaling Jenkins horizontally, meaning you start, usually people start with 1 and you just add more Jenkins servers to the fleet. This is a pretty common way to go. This is actually the officially recommended way. And each Jenkins servers can handle probably tens of thousands of tests a day. So it's actually a pretty tempting way to go. And companies like Uber and Netflix, I think Pinterest at some point, they all went down this path. But the maintenance work you need to do will also scale worse than linearly with the number of Jenkins instances you have. And also, like, another bad thing about this is that these are not like your web servers, right? When you scale your web servers, they will hide behind load balancer, and then they will still act as one website from the user's perspective. Jenkins is not designed to work like that. Jenkins is designed to act as each of these Jenkins servers would have to act as a standalone platform. And you would have to like just kind of manually assign your teams to say, oh, team A should go to this Oscar Jenkins, and team B should always use this Sherlock Jenkins, and don't use other people's Jenkins because your jobs wouldn't be on there. So that's in their overhead. And for larger companies, it's pretty common to have 20, 30, or even more of these, right? So if we get to that scale, it's like we're using people as infrastructure just to keep our servers running, just to keep our tests running. And we just didn't think that that's the way to go. So we decided we would spend some time trying to scale our existing platform and to stop them from failing all the time. so that we can free ourselves up from fighting fires all the time. And then when we actually have time, we would think about switching to another platform. So we started looking at this. And luckily, we had some pretty granular metrics collected on our build and also like our worker system metrics. So once we started looking, we found some problems immediately. So here, if you look at the graph on top, well, these are not very good graphs, but anyway, if you look at the graph on top, you can see that this is the number of builds by day, per day, grouped by the different Jenkins servers we had. So you can see that the purple and the pinkish color, these two are the testing Jenkins servers I was talking about. And they were obviously handling the most load, and also it seems like they're handling roughly the same amount of tests as well. But the weird thing was one of them were performing visibly worse than the other one. So why is that? We look into it a little bit more. And if you look at the graph on the bottom, we notice this one is like the number of long-running jobs we have per day. And we notice that whenever there's a spike in the number of builds that take longer, the Jenkins server that's supposed to handle these loads will almost certainly fail. And it turns out, of course, the server that was doing worse was the one that handled more of these kind of builds. So what was happening here is that we have a few thousand integration tests that run for a specific service if you touch it. So for each commit that touches this service, these tests will get parallelized between 30 builds to run, and each of them would take about 30 minutes to finish. Because these are some really resource-heavy tests, we could only put 2 of these on one worker node at one time. So that means one commit will make 15 workers unavailable for anything else for 30 minutes. And if we have 10 commits come in during that 30-minute period, which for us happened quite often, we will need 150 workers just for the integration tests. The Jenkins server needs to keep a connection open to all these workers. And it also needs to orchestrate every step that happens on every running job. So those 2 things can easily overload the server when there's a spike in these kind of jobs. So based on this information, we decided to temporarily offload our jobs onto this AWS CodeBuild service. I said temporarily because we looked at this service and it was pretty clear that it's not flexible enough for our needs. If we want to use it, we have to use Jenkins to orchestrate the things happening on CodeBuild. We can only use CodeBuild as a worker and not a server. And it's way more expensive than Jenkins. It charges by the minute. So it's actually 60 times more expensive than our regular Jenkins workers. So we definitely didn't want to pay for it long term. But we still went for this because it was really easy to integrate. I was able to make a proof of concept pipeline in like 2 or 3 days. And we offloaded the whole integration testing within like 2 or 3 weeks. So it was really easy to do, and so we spent some short amount of time, and then that bought us a few months of time to work on other things. And then the more important thing here that we realized later was that CodeBuild uses this YAML format that we talked about for pipeline configuration. While it's not flexible enough, the nice thing about it is it kind of forces us to take parts of our logic out of Groovy and put them into portable command line tools or scripts. And once we put them, we take them out of Groovy and put them in somewhere else, they become runnable on any other platform. So just by moving some of our tests onto CodeBuild, we have freed ourselves from Jenkins a little bit more. Does that make sense? And then, yeah, so what this looks like after we did it is that instead of having, for each command, instead of using 15 workers, we only need one, and the only thing that this one worker is doing is that it's just pinging CodeBuild once in a while to see if the job finished yet. So for the Jenkins server, this is great because it doesn't need to connect to as many workers, and also it doesn't need to orchestrate as many steps as on the running builds as it did before. So this was actually the biggest return on investment thing that we did during this time. And we tried to improve our Jenkins performance for a few months. And at the end of it, we did pretty good. Each of our Jenkins servers could handle like 80,000 plus builds a day, versus before at the beginning of 2019, they were doing 25,000 a day each and failing all the time. So this was nice, but it was pretty clear that we had pushed these Jenkins servers to the limit, and we couldn't possibly scale that further. Like even like the CloudBees, which is the enterprise Jenkins company, like we've talked to them, and even they are like surprised by how many builds we're running on each Jenkins servers. So it was pretty clear that Jenkins is not defined to run more than tens of thousands of builds a day. And if we want to scale it further, quote unquote, scale it further, we have to go back to the multiple servers way. And on top of that, after all this work, we really only tackled the scaling problem. We didn't even touch the slowness or the flakiness. So we started to feel like if we want to do something about those, maybe it's time to do it on another platform. And at this point, we had more teammates on the DevTools team, and we just had more time and resources in general. So we started looking. So, yeah, to help us decide, we made a matrix like this. And so in reality, it's obviously larger and like larger matrix with more criteria and more options, but here I just shrink it down so that it would fit on the slide. You get the idea. Yeah, so here's how you fill it out. Now for each option you do Jenkins. Well, flexibility is really important for us because we have a lot of logic to decide what should run and what should not, because we have a mono repo that basically has everything in it. We have Python code, we have Kotlin code, we have batch jobs, ETL pipelines, like literally everything. So a lot of logic need to be decided at runtime to see it. Based on what you touched, what tests should be run. So that's the most important thing for us. Jenkins can do whatever you want. So that's a green for Jenkins. Scalability, while we don't like the way it scales, it's possible. So I give it a yellow. But on maintainability, I give it red, because again, the amount of maintenance work you need to do scales with the amount of Jenkins instances you have. And also, like, you need very specific Jenkins knowledge to know how to not overload the servers. And you just really need to be really careful to make them not catch fire all the time. So I would say it's hard to maintain once you reach a certain scale. And yeah, next up, I'll just introduce BuildKite, the platform we end up using, see how it scores on these criteria. So BuildKite is this hosted platform, bring your own worker platform. We already talked about this. On flexibility, it allows dynamic generated pipelines. That's really all we wanted. It does it like this, again, we talked about this. So over here, this blue thing is the pipeline upload logo icon. So this means I generate my pipeline, and then the rest of these will show up after your pipeline is generated. And the nice thing, again, we talked about this, you can choose whatever language you prefer. That's really a big plus. No one really liked Groovy or Java, I guess. So it's also more flexible than Jenkins on that. And every step of the pipeline is customizable. You can, oh wait, I see some chats. Sorry. Yeah, so every step of the pipeline is customizable. It really, my first impression about BuildKite was that it really focuses on flexibility. You can define these hooks, so scripts to run on basically every stage, like pre-checkout, post-checkout, pre-exit, and like it gives you a lot of options to configure things the way you want it to run. And on scalability, just according to BuildKite, it says you can connect up to 10,000 workers without having any problems. And we ran some stress tests to verify the claim, and we were pretty satisfied with the result. So as a comparison, on Jenkins, we probably across 4 of them, we probably connect 2,000 to 3,000 at peak time. On BuildKite, we just regularly run 4,000 every day, and when load is heavy, we probably would run like 5,000 or 6,000 just daily. And another thing I want to call out here is that BuildKite is the only, out of the 10-ish platform that I've looked at, BuildKite is the only one that had put a specific number on scalability on their website. So this just tells me, I think they're really confident about the way they scale. Compared to some other platforms, they would not talk about it, but then they will charge you based on the number of concurrent builds you run. Then that's just kind of discouraging you from parallelizing your builds. And that just, when you see that kind of pricing point, you just you're gonna kind of tell that they don't scale very well. Yeah, and then maintainability, you again host the platform, you don't care about server, you only care about the pipeline and and the workers you manage. And then because we could choose whatever language we prefer for generating the pipelines, we chose Python, which is actually the major language of our backend code. So that means we can reuse our testing framework for our backend code to use on our CI code. So we can run CI on our CI configuration code, which is great. We never had that with Jenkins. And on BuildKite, you don't worry about a single point of failure anymore. So on Jenkins, because the server orchestrates every step of every running build, you just have to keep an extra eye on the server, because once the server gets slow, everything gets slow. And it's really easy for one corporate job to bring down the whole thing. On BuildKite, that's just not a problem anymore. So, well, I filled it out because we don't have much time here. But anyway, you can see at a glance, BuildKite is the clear winner here. All three things are pretty green, so that's where we move to. Now so we designed this. This on BuildKite, we had this pipeline where for average non-infra engineers, microservice owners or library owners, they just look at a simple YAML, and then we have a pipeline generator that reads this YAML to see what your service or what your library needs to test, and then that would generate YAML in BuildKite format. So it looks something like this. So non-infra engineers, they will configure, like on the left is a service configuration, and then on the right is the library configuration. So you can say things, oh, my library needs a large instance to run tests on, and I also need a mock SQL database. It should time out in 5 minutes if it hasn't finished yet. So for normal engineers, what they see is really, really simple, and this also limits what they can do. In the past, on Jenkins, we had problems where, because everyone just wrote Groovy for their jobs, sometimes people do random things that we can't catch. That would slow down everyone. On BuildKite, because we define this boundary and say everything has to go through our pipeline generator, right? This just limits the number of things other people can do, and just makes everything safer. Yeah, so this is what it looks like. Again, the blue icon over here is the generation, and then all of everything else magically appeared after the pipeline gets generated. And this is just a look at what the pipeline generation step look like. So here you can see it's uploading pipeline, and down there, this YAML file is actually thousands lines long, so we can't possibly write that and just store it as a static YAML file in our repository. So we spent about 10 weeks on moving to BuildKite, which is I would say it's a pretty short amount of time given the results we had. And the migration itself wasn't hard. The hard part was really deciding where we should move to and making sure that we wouldn't waste the time we spend on migrating. So after we migrated everything to BuildKite, our build failure rate dropped from 44.6% to 15.7%. So the difference there were mostly the flaky tests that I was talking about. And our testing pipelines used to run between 20 to 70 minutes. Now it runs between 2 to 14 minutes, depending on which service you're testing. And then the max number of builds a day, we pushed Jenkins really hard. And across 4 Jenkins servers, our record was 164,000 builds a day before we shut it down. Now on BuildKite, we just regularly run over 600,000, and it's pretty clear that it can do way more than that. And our changes really had a really positive effect on our engineers as well. Our developer NPS score went up by 54. NPS, by the way, stands for Net Promoter Score. It's just a way of measuring how happy people are about something. So it goes from a scale of -100 to 100. And comparing the score before and after BuildKite, it went up by 54. So I think that's pretty good. And our engineers doesn't need to context switch as much as before because their tests finish so fast. They can pretty much iterate way more quickly than they did before. And now if they see something fail under commit, they are way more willing to actually take a look right then rather than rerunning everything a few times. And then the developer tools engineers are also happy because they spend way less time solving other people's problem, and they'll have more time on building new tools for everyone. Cool, some takeaways. So first one is that metrics are great. I was really happy that we had granular metrics collected on Jenkins. This was not just for helping us find where our problems were, but also when we moved to BuildKite, metrics allowed us to decide early on that BuildKite is indeed a better platform because just from a small batch of builds, we could already see every metric we have, BuildKite is performing better. So having metrics collected from your CI system, not just from your prod environments, is really important in helping you finding issues and also just benchmark things. Number two is that if you use self-hosted platforms, definitely look into it, understand how it runs. I would say we didn't understand Jenkins as much as I wanted to at the beginning. We kind of got forced into learning about Jenkins later when it started to have problems. If we knew how it was designed and how it ran internally earlier, we probably wouldn't have done some things we did. And that would have saved us some time. And number three is that, remember we did an intermediate step from Jenkins to CodeBuild before we did from CodeBuild to BuildKite. I feel like before we started doing this, everyone kind of wanted to just go from Jenkins to the destination in one big step, right? But we just didn't have the capacity to do it right then. And by doing an intermediate step, moving some things to CodeBuild, it really wasn't a detour. It helped us, like a few weeks bought us a few months of time. And also, while doing that, we also moved our builds and made them way less dependent on Jenkins. So I think it's important to remember that sometimes if you can't get to your destination, it's okay to find some middle ground and see if you can do part of the things first and do the other part later. Yep, that's it from me. Any questions? I see a question in the chat. Someone asked, can AWS code work alone for GitHub repo? Because we currently combine it with CircleCI. Yes, it can. Actually, AWS offers this, what's it called? AWS offers a suite of building and releasing tools. So specifically, you have code pipeline and code build and code deploy. So code pipeline is what you would use together with code build to have a pipeline of, say, a commit comes in, then you would like build, and then you would test, and then you would deploy. It's pretty straightforward. We didn't use it because it's not flexible. It doesn't really allow any conditions or like just dynamically generated pipelines. You have to configure everything. You have to configure everything in beforehand. And also another weird thing was that you kind of have to use CloudFormation or Terraform to generate your pipelines, which was also kind of a downside for us. We would rather not, well, we use Terraform for everything else actually, but for our pipelines, we felt like Terraform was overkill. We would rather just generate it ourselves. Let me look at if there's any other questions. So yeah, someone asked about Azure. I already talked about Azure. I think it's, from the look of it, I think it's closer to CodeBuild and also Server CI. And Azure also has the thing that they charge per parallel build. It's actually $15 per extra parallel builds. So if you have 10, then that's $150. If you have 100, then it gets pretty expensive quickly. Yeah, so for us, when we were choosing platforms, we were definitely not looking at the ones that would charge per parallel build. BuildKite charges per user, which is a way more reasonable pricing plan for us, because we just knew that we were gonna run thousands and thousands of concurrent builds at any given time. Charging by concurrent build, it would just not work for us. Another question is that, what made you make the decision to move to BuildKite based CI? What would you do differently if you redid the migration? I think I explained why we moved to BuildKite. Basically, first we found out that Jenkins was not designed to scale to the scale that we wanted to. And then among the different providers, BuildKite, we had, let me go back in my slides. So among the different providers, we had these criteria that we ranked from the most important to least important for us. And BuildKite scored high on the most important 3 criteria that we had. So this was mostly why. If I want to redo it, I feel like we did a pretty good job of the migration, honestly. Again, the migration is not the hard part. The hard part was deciding which one to go to make sure that we don't waste time on migrating. So if we were to redo it, I would insist on moving to BuildKite quicker. There was a period of time when I really wasn't sure whether Jenkins was not the right solution. And I probably wasted more time deciding than migrating. So if we were to redo it, I would definitely make the call sooner. The next question is, what do you see CICD in the industry, both in midterm and long term? Are there going to be some dominant players or standards winning out? I would say dominant players. Let's go back to the slide where we have everything. Oh, I have so many slides. I wonder if there's a better way to do this. Wait, here. Yeah, so these ones, I would say, so they all serve different customers. That's the thing. They focus on different, every company have different needs. Like Buddy, we will never use Buddy because like it's too not customizable and too fancy, too expensive for a company our size. But again, if they definitely have their target customers. And Jenkins, even though I don't like how Jenkins scale, Jenkins will probably always be there just because it's open source and it saves money running it. I would say I would put my money on BuildKite because we use it. I know for sure that a lot of other tech companies, larger ones, have all switched from Jenkins, especially the ones that were using Jenkins before. Some were TeamCity. I know some used CircleCI or Travis before. So I know a bunch of these larger tech companies that are in like the thousands of engineers range moved to BuildKite. So that's a really good sign. They don't even, so BuildKite doesn't even do marketing yet. It's just purely word of mouth. So yeah.
Am I understanding correctly? If, let's say, I'm about to start a startup and I have no background in CICD, then maybe Buddy, the one you won't recommend, is actually a good one to start with.
Yeah, exactly. Okay. I would say both Buddy and BuildKite. I think BuildKite is actually what fits from start to end, but I would say Buddy is more like out of the box. Everything is configured for your solution. So maybe Buddy. And if you really want to save on money, then Jenkins and BuildBot. And then another thing is that all 10 of them are free if you're doing open source projects. So so for open source, you don't worry about pricing. And for standards, I really want more platforms to support the hybrid like hosted platform but bring a worker sort of way. And then also I really want people to support the generate YAML and then upload dynamically configuration thing. Right, more questions. How to handle the artifacts in CI/CD pipeline, including build binary and Docker image. All right, great. This is also different depending on what you're using. On Jenkins, I'll just talk about the ones I used. On Jenkins, basically everything's saved on the server. If you have build artifacts like text file and stuff, they all get sent back to Jenkins, the server, and saved on there, which is not really great because you might have these problems and that will turn into performance problems. But if you just have a small number of files, that's totally fine. For CodeBuild, for Docker, everyone can upload to Docker Hub or ECR, and you can pull from there. Let's just talk about artifacts like files and jars and stuff. AWS CodeBuild, I think, supports uploading to S3. They definitely do, and I think there are some other ways. Maybe they support Artifactory. I'm not exactly sure. BuildKite also supports S3. Another interesting thing I forgot to say was that BuildKite supports both the artifacts and the logs to be saved in your S3 buckets. So that's a big plus on security. Right? we were worried about, at first we were kind of worried about maybe we were leaking things we shouldn't leak in our build logs. But since BuildKite and like, if we have to store our logs in there on their server side, then that would be a concern for us. And then BuildKite offered to store our logs in our S3 bucket and then just render it when we need it. So that was also a big plus. Do you have any idea about DevOps positions? There are many positions on the market, but most of them require at least 3 years experience. Yeah, I don't, only because I realized that the word DevOps means very different things at different companies. So at some companies, DevOps are just the same as other engineers. You just work on, besides you work on tools for other engineers, then you work on, instead of working on backend or the apps. But I've also seen a lot of places where DevOps literally means you manually configure a Jenkins server for a team, and then you look after this Jenkins server for this 10 people team. So there's a really wide range, I guess, depending on where you're looking at. It's a wide range. Yeah. So it's also really hard to hire for DevOps engineers because of this. We get a huge variety of candidates. Like the years of experience doesn't necessarily matter here. It's just that some of them, the way their company do things, it's just so different from the way we do things that they have a different understanding of DevOps. And we want to hire engineers, but they're actually not engineers, so that would not be a match for us. How large was the DevTools team versus the entire Int team back in 2019? Oh, yes. Back in 2019, we had about 200 engineers. Now we have 350. Yeah. So back in the first half of 2019, I was working alone on the DevTools team. Later, so I think starting in June, July, I had more people join me. By the end of, now we have, not on DevTools team anymore, actually. I wanted to work on something else. But now the DevTools team is like 4 or 5 people. So 4 or 5 people supporting 350. So the idea is that we really want to automate everything as much as we could. And the tools team should really be the tools team that build tools for people and not the team that look at why people's build fail kind of job. Is there any improvement that you would like to see in BuildKite? Yeah, one thing that I know a lot of people wanted was that, so again, BuildKite focuses on flexibility and scalability, right? It's not as big on UI. So, I mean, its UI is pretty clean and pretty simple, but it definitely has something we want there. Like when you click start a new build, right now it doesn't give you the flexibility of like configuring what that kickoff a new build dialog look like. This was possible in Jenkins. It's probably possible in a bunch of other platforms as well, but currently BuildKite doesn't offer that. This is slightly a problem because like for like some builds we automate the kickoff, but for some other builds, like if an engineer just wants a dev environment spin up for themselves, then they kind of have to do that pass in like their requirements through environment variables instead of, like nicely fill in, oh, my environment name should be this, and it should be using this service and that service. So that's kind of, I hope that's on the roadmap. Is there a time that you guys running build on VM and container at the same time? Like if you're on Jenkins and AWS CodeBuild at the same time, any issues? We had Vagrant for a while, but that was before my time on DevTools. By the time I started working on this, we were all on Docker. So I didn't need to support two systems there, which is great. But yes, we were on Jenkins and CodeBuild at the same time because, like, again, CodeBuild is not flexible enough for our need. We have to keep Jenkins as an orchestrator. Jenkins will use CodeBuild as a worker, and Jenkins still just initiate the build, and CodeBuild would run the sequence of things and then report back to Jenkins that the builds have finished. The biggest issue with that was when a build failed on CodeBuild, engineers would need to log into two different systems to see what's wrong with their builds. Because, like, well, CodeBuild support showing logs in Jenkins, but because we run so many builds, and like all the logs get saved on Jenkins, the Jenkins server, we didn't turn that on. Like, we just couldn't let that much logs flow back to Jenkins server. That alone would create problems. So our engineers had to, if they see their build fail on Jenkins, they would then log into AWS to see the logs, and that was a huge pain. And that was another reason why we didn't want to keep it long term. How do these tools handle credentials differently? Or do you always store credentials in some remote store? This is a great question. So on Jenkins, again, everything is saved as files on the server node. So if you have secrets, they get somewhat encrypted, and then they get saved as a XML file on the server node. On BuildKite, we use, and AWS CodeBuild, I think most of them support AWS. It was a key management store. I think it is KMS, key management store. So because we use AWS for everything else, we trust AWS with our secrets. I think BuildKite also supports Vault, which we also use Vault, but for this purpose, we didn't feel like that was necessary. Yeah, I'm not so sure about the other ones. I would guess either saving it on the server, which is actually a dumb idea, or some key remote store would make sense. Still, you need secrets to connect to the remote store. Yeah, like not sometimes, depending on how you want to configure it. I don't know how it works in other cloud providers, but on AWS, you can either use secrets to connect, or you can use IAM permissions. Like, you can say these machines are allowed to read these secrets. We talked a lot about CI. What about CD? What tool are you using? So currently, because of the security concern I talked about BuildKite, we are still using Jenkins for CD, which is why I didn't talk about it. And it's still the same as it was before. So we are hoping that we would do more of the, like, we'll work on some projects to make our BuildKite environment more secure. And at some point, when we feel like it's secure enough for us, we will start moving our deploy pipelines over to BuildKite. Do you guys use Docker container as build environment from day one? We definitely didn't. I think we used, well, when I got to a firm, we were using Vagrant, but I didn't, at the time I was working on mobile apps, so I didn't get to actually use Vagrant. And by the time I moved to infra, we were using Docker for everything. So I would say we're using VM for the first, I can't remember how long, but we've been on Docker since probably 2017 or 2018. Yeah. All right, I think that was all the questions. I got a lot of questions.